UL-listed welding cable is permitted for use as a permanent wiring method when compliant with Article 310 of the National Electrical Code. Further, the application of the cable must adhere to the manufacturer's instructions. The cable must not be exposed to conditions that could result in physical damage. Considering a permanent installation using welding cable, one must ensure adherence to these requirements and, most importantly, confirm that all termination devices used are both listed and properly rated for the specific application. The National Electrical Code's Article 310 addresses conductors for general wiring, including their ampacity, insulation, and other characteristics. This article provides guidance on selecting the appropriate conductors for various applications based on factors such as voltage, temperature rating, and installation environment. When using welding cable as a permanent wiring method, it is crucial to consult Article 310 to ensure that the cable meets the requirements for the specific installation. This includes verifying that the cable's ampacity is sufficient for the intended load, that its insulation is suitable for the operating temperature, and that it is installed in a manner that protects it from physical damage. The manufacturer's instructions provide essential information on the proper handling, installation, and termination of the welding cable. These instructions may include specific recommendations on the type of connectors to use, the tightening torque for connections, and other precautions to ensure a safe and reliable installation. Failure to follow the manufacturer's instructions can void the cable's warranty and increase the risk of electrical hazards. Protecting the welding cable from physical damage is crucial to maintaining its integrity and preventing electrical faults. This may involve routing the cable through conduit, using cable trays, or providing other forms of mechanical protection. The specific type of protection required will depend on the installation environment and the potential hazards present. When selecting termination devices for welding cable, it is essential to choose devices that are specifically listed and rated for use with this type of cable. Welding cable typically has a fine-stranded construction, which requires specialized connectors that can provide a secure and reliable connection. Using the wrong type of connector can result in loose connections, overheating, and even electrical fires. The termination devices must also be rated for the voltage and current of the circuit in which they are being used. Overloading the termination devices can cause them to overheat and fail, leading to electrical hazards. In summary, while using UL-listed welding cable for permanent wiring in DC power systems is permissible under the National Electrical Code, it is essential to carefully consider all applicable requirements and recommendations. This includes complying with Article 310, following the manufacturer's instructions, protecting the cable from physical damage, and using properly listed and rated termination devices. By taking these precautions, you can ensure a safer and reliable installation. Regarding the commonality of welding cable being listed as type RHH or RHW, these are indeed common insulation types for welding cable. RHH indicates a rubber heat-resistant insulation, while RHW indicates a rubber heat and water-resistant insulation. These insulation types provide the flexibility and durability needed for welding applications, and their listing ensures they meet specific safety and performance standards. When selecting welding cable for a permanent installation, it is essential to verify that it is listed and marked with the appropriate insulation type for the intended application. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for electrical installations in the United States. It is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. Article 310 of the NEC covers conductors for general wiring, including their ampacity, insulation, and other characteristics. This article provides guidance on selecting the appropriate conductors for various applications based on factors such as voltage, temperature rating, and installation environment. In addition to Article 310, other articles of the NEC may also be relevant to the use of welding cable as a permanent wiring method. These may include articles on wiring methods, grounding, and overcurrent protection. It is essential to consult the latest edition of the NEC to ensure that all applicable requirements are met. The manufacturer's instructions provide essential information on the proper handling, installation, and termination of welding cable. These instructions may include specific recommendations on the type of connectors to use, the tightening torque for connections, and other precautions to ensure a safe and reliable installation. Following the manufacturer's instructions is crucial for maintaining the cable's warranty and preventing electrical hazards. Failure to do so can result in loose connections, overheating, and even electrical fires. Protecting welding cable from physical damage is essential for maintaining its integrity and preventing electrical faults. This may involve routing the cable through conduit, using cable trays, or providing other forms of mechanical protection. The specific type of protection required will depend on the installation environment and the potential hazards present. For example, in areas where the cable is exposed to abrasion or impact, it may be necessary to use a more robust form of protection such as rigid metal conduit. In areas where the cable is exposed to moisture or chemicals, it may be necessary to use a corrosion-resistant conduit or cable tray. When selecting termination devices for welding cable, it is essential to choose devices that are specifically listed and rated for use with this type of cable. Welding cable typically has a fine-stranded construction, which requires specialized connectors that can provide a secure and reliable connection. Using the wrong type of connector can result in loose connections, overheating, and even electrical fires. Termination devices must also be rated for the voltage and current of the circuit in which they are being used. Overloading the termination devices can cause them to overheat and fail, leading to electrical hazards. In addition to using properly listed and rated termination devices, it is also important to ensure that the connections are made correctly. This may involve using specialized tools, such as crimpers or torque wrenches, to ensure that the connections are tight and secure. It is also important to inspect the connections regularly to ensure that they remain tight and free from corrosion. When using welding cable in a DC power system, it is important to consider the voltage drop that may occur over the length of the cable. Voltage drop is the reduction in voltage that occurs as current flows through a conductor. Excessive voltage drop can reduce the performance of the equipment being powered and can even cause it to malfunction. To minimize voltage drop, it is important to select a welding cable with a sufficiently large conductor size. The larger the conductor size, the lower the resistance and the less voltage drop that will occur. It is also important to keep the length of the cable as short as possible. In addition to voltage drop, it is also important to consider the ampacity of the welding cable. Ampacity is the maximum amount of current that a conductor can safely carry without overheating. The ampacity of a welding cable depends on its conductor size, insulation type, and installation environment. It is important to select a welding cable with an ampacity that is sufficient for the intended load. Overloading a welding cable can cause it to overheat and fail, leading to electrical hazards. When using welding cable in a battery system, it is important to consider the potential for corrosion. Batteries can release corrosive fumes that can damage electrical conductors and connections. To prevent corrosion, it is important to use welding cable with a corrosion-resistant insulation. It is also important to protect the connections from exposure to battery fumes. This may involve using sealed connectors or applying a corrosion-resistant coating to the connections. In summary, using UL-listed welding cable for permanent wiring in DC power systems is permissible under the National Electrical Code, but it is essential to carefully consider all applicable requirements and recommendations. This includes complying with Article 310, following the manufacturer's instructions, protecting the cable from physical damage, using properly listed and rated termination devices, minimizing voltage drop, ensuring adequate ampacity, and preventing corrosion. By taking these precautions, you can ensure safe and reliable installation. The decision to use welding cable for permanent installation should be based on a thorough evaluation of the specific application requirements and a careful consideration of the potential risks and benefits. It is important to consult with a qualified electrical engineer or electrician to ensure that the installation is safe and compliant with all applicable codes and standards. The National Electrical Code is not intended to be a substitute for sound engineering judgment. It is important to use your knowledge and experience to make informed decisions about electrical installations. If you are unsure about any aspect of an electrical installation, it is always best to seek professional advice. When considering the use of welding cable for a permanent connection on a 24 volts DC system used to power a cabinet and maintain a battery stack, several factors must be taken into account. Firstly, the welding cable must be UL listed and rated for the intended application. Secondly, the cable must be sized correctly according to NEC 400.5 and other relevant sections to ensure it can handle the current load without overheating. Thirdly, the termination points must be properly rated and installed to provide a secure and reliable connection. Lastly, the installation must be protected from physical damage to ensure the long-term integrity of the wiring system. The type RHH or RHW insulation commonly found on welding cable provides excellent heat and moisture resistance, making it suitable for many permanent installation applications. However, it is crucial to verify that the specific welding cable being used is indeed listed for permanent installation and not just for intermittent use, as some manufacturers may produce welding cables specifically designed for temporary applications. In addition to the above considerations, it is also important to take into account the environmental conditions in which the welding cable will be installed. If the cable is exposed to harsh chemicals at extreme temperatures or other adverse conditions, it may be necessary to use a cable with a more robust insulation or to provide additional protection to the cable. Furthermore, it is important to ensure that the welding cable is properly supported and secured to prevent it from sagging or rubbing against other objects. This can help to prevent physical damage to the cable and ensure that it remains in good condition over the long term. When connecting the welding cable to the battery stack, it is important to use connectors that are specifically designed for use with batteries. These connectors should be made of a corrosion-resistant material and should provide a secure and reliable connection. It is also important to ensure that the connectors are properly sized for the welding cable and the battery terminals. In addition to the above considerations, it is also important to follow all applicable safety precautions when working with electrical systems. This includes wearing appropriate personal protective equipment, such as gloves and eye protection, and energizing the circuit before making any connections. It is also important to be aware of the potential hazards associated with batteries, such as the risk of explosion or fire. The NEC provides detailed guidance on the safe installation and maintenance of electrical systems. It is important to consult the NEC and to follow all applicable requirements when working with electrical systems. If you are not familiar with the NEC or with electrical work in general, it is best to consult with a qualified electrician.